Hi, I'm Mel and I wanted to talk in this short video about ocean acidification. This just is the colour that a universal indicator will change in the presence of different pHs. If a pH is very low, that means that there's a lot of acid. That's something like vinegar or lemon juice, or something like tap water would have a more neutral pH. Then we move up into alkali or basic solutions that have a very high pH. Oceans generally have a pH of around about 8. There's been some salt and some other minerals that are dissolved in seawater, and that has raised the pH a little bit up from its neutral level. Now that's really important because there's a lot of things that live in the ocean that rely on the pH being at around 8 so that they can get the minerals that are dissolved in the ocean into their bodies so they can form shells. Corals can grow. There still seems to be some evidence that ocean acidification would hurt things that are growing in the ocean. And it only needs to change the pH a little bit because it's a log scale, so a little change in pH actually relates to a big change in composition. What I've got here are some water solutions that I have added some of this. This is a indicator solution. This here is just some tap water. I didn't have any seawater because I'm in Oxford, it's quite a long cycle, so this is just some water with bicarbonate of soda added. CO2 or carbon dioxide is a natural gas that's present in the atmosphere. Now, carbon dioxide can actually dissolve into water and it can form an acid called carbonic acid. So if I just show you this, we humans breathe in air, we use the oxygen, and then the water we breathe out is rich in carbon dioxide. This is the one that I blew into, so it's got more CO2 in it. This is the one that was just tap water. So carbon dioxide is naturally present in the atmosphere. It's something that we would expect to be there, but the problem is that it's not usually present in the high concentrations that we're seeing at the moment. So looking back through the records, we can see that since the Industrial Revolution, as we've relied more and more on fossil fuels, on burning fuels for our cars, burning fuels for our aeroplanes, burning fuels for our power production, all of these things have increased how much carbon dioxide is present in the atmosphere. Now obviously there's been a lot of talk about how increasing carbon dioxide and other greenhouse gases can increase the temperature of the Earth and how that can lead to global warming. But there's also been this discussion about how if we increase how much carbon dioxide is present in the atmosphere, we can increase how much carbon dioxide gets dissolved into the oceans, and we might start to acidify the oceans. So what I'm going to do now is get a bigger bottle of my seawater sample and add some solid carbon dioxide, some dry ice, which will form a carbon dioxide gas as soon as it hits the water. Seawater, here's my increase in CO2. You can see that pretty violent reaction there. So you can see the carbon dioxide is quickly turning into CO2 gas. So this is quickly flooding this water here with carbon dioxide gas. And you should be able to see that that colour is changing pretty quickly, and it's going to really change the chemistry of the seawater.